Selamat pagi ya para peserta AR 3250 struktur dan bentuk. Hari ini kita akan mengadakan kuliah tamu. Kita kedatangan dosen tamu dari School of Architecture University of Wellington, New Zealand, Profesor Andrew Charleson. Profesor ini adalah yang mengarang buku itu ya, Structure as Architecture. Mungkin kalian sudah pernah baca. Jadi Profesor Charleson ini sedang ada program visiting professor di Universitas Parahyangan selama 3 bulan. Jadi beliau sangat senang diundang ke Prodi untuk memberikan kuliah tamu terkait dengan ekspertis beliau ya. Jadi saya bacakan research interest dari Profesor Charleson. Itu yang pertama itu adalah how structure of buildings can enrich their architecture. Yang kedua, earthquake engineering and architecture. Yang ketiga, earthquake damage mitigation in developing countries. Jadi topik kuliah tamu yang akan beliau bawakan ini sepertinya sangat relevan dengan mata kuliah 3250 ya. Structure as reinforcement of design concept and architectural quality. Baik, untuk selanjutnya nanti Pak Andri yang akan membawakan sesi tanya jawab ya sebagai moderator. Baik, untuk selanjutnya saya serahkan ke Profesor Charleson ya. Profesor, the time is yours.
Well, good morning, students.
Morning.
Please, I don't think, can you hear me?
Yes.
I prefer to stand, if that's okay. Please forgive my using the English language. I was explaining to your professors that 35 years ago, I lived in Bandung for 2 years. And I worked at DPMB, which is now called Pushkin. And so after 35 years, my wife and I have returned to Bandung, and we feel it's a bit like coming home, even though we've not visited here for 35 years. And I'm very pleased to come and give a lecture at ITB. When I was in Bandung formally, I actually taught an earthquake engineering course at ITB. So this is not my first lecture at ITB. So today, this is the topic of my lecture. And I think you understand that when we design structure, when we insert structure into our buildings, people are going to make a reading of that structure. And actually, I'm very intrigued by the structure in this room today, because the structure is very dominant, isn't it? These two columns, they are very dominant in this space. And actually, my reading of the structure is that it's sort of confining us. These two columns have a very strong effect on confining us into this narrower width. And so you students can't sit over there because it's impossible to see. And so whenever we as architects design structure, we always have to realize that people are going to make a reading of it. They're going to have an opinion about it. And so the structure becomes an essential part of our architecture. And this lady, Fontaine, she's a lecturer in the School of Architecture in Canada, and she writes about a particular column in the foyer of her School of Architecture. And she says, this column plays a pivotal role in the building and establishes structure as a primary ordering device in the architecture of her school. And it has the palpable effect of anchoring the life of the school. And so in her particular School of Architecture, there's one column that is just so significant in the way it affects the space of her school. And probably in a similar way, these two columns, they have a very significant effect on the space of this particular room. I just want to say that as I go through my lecture, I'm very happy for you to interrupt and ask me questions. Okay? I like to keep it very informal. So if you have a question or a comment, just we will address that as we go. And then another academic, actually from Canada, also comments on the way that structure can be read. And he says that it's impossible not to read the arches of the Tama Art Library. That's a design by Toyo Ito. It's impossible not to read them as a sign, as a reference to a recognizable form and within classical architecture. They are that, but they are many other things too. Toyo Ito produces work that is richer and more nuanced, precisely for its capacity to hold these multiple readings in a delicate equilibrium. And that would be possibly one of the definitions of a great work of architecture, that the structure is bringing multiple readings and they are in equilibrium. Just before I continue, I'd like to ask you a question. What is the difference between a building and a work of architecture? What is the difference between a building and a work of architecture? And I want you to tell the person sitting next to you what your thoughts are. Okay? I'll give you a couple of minutes.
Kalau building itu mencapai tahun.
Okay, would anyone like to give me what you think is the main difference? Yes.
What I think the difference between building and work of architecture is that work of architecture, it has designing it was created to make a space for a human to live in it. The difference between architecture design and just buildings that, for instance, like a port or just a structure is just a building like that. But work of architecture is like it's just like this room. It's designed to accommodate people to work, live, and do stuff in it. That's all.
Okay. Have you got any other opinions? Please use Bahasa Indonesia if you'd like, and I'll ask one of our professors to translate if I can't understand. Well, look, it's very important. You have a very strong opinion about this question. For me, a work of architecture is different from a building because a work of architecture will express something. Anything. But it must be strongly expressive of a design idea. But it could be expressive of its environment or of its cultural setting. But that's what, for me, distinguishes a work of architecture from a typical building. Most buildings are not expressive of anything. You know, you think of the buildings that you occupy day to day, and I'm sure over 90% of them don't express anything to you. To me, that is not architecture. That is building. And then we have this quote here from an English philosopher, and he says that since objects in an art gallery or museum can speak to us, and since pencil lines that we can draw on a piece of paper can convey emotions like peacefulness and confusion, it should come as no surprise that buildings, their form and their exposed structures that support them also speak. It should not surprise us. And Boton notes how we can be emotionally moved by the way a column, say, connects with a roof. Like it might be a particularly beautiful connection. And so I just want you to do a little exercise for me. I'd like you to just draw, say, 3 lines on a piece of paper. Draw the first line so that it creates a feeling of peacefulness. The second line I want you to draw that expresses confusion. And the third line I want you to draw is boring. Okay, draw those 3 lines, please. I want everyone to draw those 3 lines. Peacefulness, confusion, and boring. Yeah, that's nice. That's great. Well done. How about you others? Yeah, that's nice. Yeah, that's certainly confusing. Great. Okay, I think you've succeeded quite well in conveying those emotions. And just those very lines they could be the start of a design concept. Because you could design a building with a concept of peacefulness. Or on the other hand, you could design a building perhaps like Daniel Leibskin's Jewish Museum in Berlin, that almost speaks of confusion and alienation. Or you could design a building for a client, and I can't imagine why, but the client might want a boring building. And so everything in plan and in section and in the detailing would probably be straight lines and really boring. And so we can use structure to reinforce these concepts. And I'm going to give you lots of examples shortly. But first I just want to explain that when I began researching for the book, my book, Structure as Architecture, I did a tremendous amount of literature reviewing in the international literature. And I visited over 400 buildings throughout the world which had been reviewed in the architectural literature to try and experience these buildings and understand why they were considered works of architecture. And then I did a lot of categorization and sorting. And in the second edition of my book, and I'm not sure if your library has, does your library have my second edition? Or just the first edition? Just the first. Okay, well in the second edition, I introduce these two chapters where I have groups of architectural concepts that I have read. And then I have groups of architectural qualities that are apparent in these buildings. And so I'm going to take you through these now and show you the way structure is reinforcing these concepts and qualities. And so we start with this, this spectrum going from a design concept of order to a design concept of chaos. So we start with order, and we begin with the master Mies van der Rohe. Here is an incredibly ordered building. Totally symmetrical, totally orthogonal, totally ordered, right? And so this was part of his philosophy, wasn't it? Part of his response to being in a modern movement. And perhaps I should say that most of the buildings we inhabit are ordered. Like, I would expect this building would be very ordered. But unfortunately, most buildings that are ordered are also quite boring. Because like contractors, they love ordered buildings, don't they? They like grids. But most of those buildings are really boring. They're not expressing anything. And so I'm not going to show you any more examples of order, because it's all around us. But it's not particularly exciting. Unless we are totally rigorous about it, like Van der Rohe was. Totally rigorous. Then we move to a museum in Melbourne. And notice the way the columns are slightly off grid and slightly slanted. And so the architect is breaking away from order. And in my view, the architect is introducing playfulness. There's an element of fun about this building. you know, and when you walk around those columns, you know, it makes you feel somewhat happy. They're different, they're interesting, they're alive. And so here we are moving away from order. And then in Vienna, we come to this building that is terribly disordered. It is a structural nightmare, almost. Look at that column there. It doesn't continue to the ground. This column, just random, between these beams. This column doesn't meet the column above. This column is kinked. And so on. And so we're starting to move towards chaos. And then we move to the new addition to the Toronto Museum, designed by Leidskin again. This is called the Crystal. And the structure inside it is just chaos. But yet it reinforces the form and it reinforces the design concept. Fantastic architecture, even though it's chaotic. What about this spectrum, going from stability to instability? Most of the buildings we inhabit sort of express stability. Like take this building here, you know, the columns are quite large, they're vertical. I mean, you could say they are somewhat expressing stability. And that's true in this courthouse in Canada. These portal frames here, you know, they're big, they're repetitive, reinforced concrete, strong material. They're very solid. They're expressing something that is static and going to not move. But then when we move to this building in Paris, we get a sense that it's almost unstable, because look how slender the columns are. It's about a 6-story building, and the columns are only this diameter, structural steel. And the beams are rather unusual, aren't they? They're curved, and they're quite slender near the columns. Actually, the beams are expressing the bending moment diagram, aren't they? So the architect had a good understanding of structures. Very good. Anyway, this building looks really unstable. And it would be unstable if it didn't have some shear walls at each end of it to support it for wind load and any earthquake load. So we're starting to get into instability. And then we go to this workshop just out of Tokyo for a polytechnic university. And the columns are actually only, at the most, 1.5 centimetres thick. The columns are tiny. And you feel as if you're walking through a forest of tiny trees. It is really amazing. The columns are so thin, and even at their maximum, they're only, I think, 6 centimetres. And so they are placed randomly in plan. Randomly. And so once again, this sense of the chaotic in plan. But yet, that chaos, it reinforces the sense of being in a forest. Now we're getting into something very unstable. This is a school of art in Toronto, and it is elevated, I don't know, 4 or 5 stories, and mainly supported on these inclined struts. They're large cantilevers. Most people would be scared to enter this building because it looks so unstable. But yet, in Canada, they have very rigid building codes and rigid QA during construction. And so I believe that building is very safe, even though it looks unstable. And here, Zaha Hadid. She loved instability, didn't she? She just loved it. And wherever she could, she wanted the structure to express instability. And here in Vienna, Here in Vienna, we see this cluster of columns, where most of the columns are actually leading to instability. But to some degree, there is some triangulation to restore stability. Because as you know, triangulation is very stable. And then we come back to Toyo Ito and his amazing building in Sendai. He has these clusters of columns, but most of these clusters are actually unstable. Like this cluster here is totally unstable because there is no triangulation, and some of the columns are sloping, and so on its own, this is totally unstable. And this is quite unstable too, this one. No triangulation. Some of the columns are sloping. It's not symmetrical. It's unstable. But there are, I think, 6 columns like this that are triangulated. And they give the building its stability. And so here is one column that is unstable. This is the column that helps give stability for earthquake and wind. And so Toyo Ito is using structure very, very effectively to communicate his design ideas. Are there any questions before I proceed? Any questions so far? Okay. Now we move on to this here, this spectrum of going from static to dynamic. And we begin with this museum in Vancouver, which in elevation is really static. Because, and also in elevation, side elevation, the building slopes. So there's a sense of the building being static, but from other perspectives, there's a small degree of the dynamic. Most buildings we inhabit are static. Like this building here speaks of static. There's nothing dynamic about the structure of this building, I believe. Do you agree with me?
Yes.
Right. We're on the same wavelength there. But then we come back to Vancouver and we visit this new exhibition building, and those slightly inclined columns make a huge difference and introduce a sense of the dynamic. You just have to move a column a few degrees and you transform it from being static to having a sense of dynamic. And when I went up into that building and I looked out over the harbour, it was terrific because the glazing was sloping away from me, the structure was sloping away, and it was an invitation to enjoy the harbour. You know, lovely architecture. And then in London we come to this building designed by Jean Nouvel. And from a distance, the building is quite boring. Like, see the vertical mullions supporting the cladding? That's what we always do. 99% of the buildings in the world do that. Nothing special. But at ground floor level, these are the mullions. They support the wind pressure on the glass. And so when the wind blows, the glass transfers the forces to these steel members that transfer the forces into the primary structure. And so this is an example of a really dynamic piece of glazing structure. And here at this school of dance in France, the exposed structure, it speaks of dancing. Can you see that? You can see can't you? The structure is telling us the story of what happens, the function of this building in a very nice way. It's not overdone, and it's all in reinforced concrete, a material that you are very familiar with. So, very dynamic structure. And this is the most dynamic of all the structure I have encountered. This is a library, I think, in a school of architecture in Germany. And actually the students came up with this concept of these columns. They studied the galloping of race horses. They took lots of photographs of horses galloping, and then they used those photographs as inspiration for the detailing of those columns. What amazing columns! They're so dynamic. And so, if you ever visit this library, you will never forget the structure. It will always remain with you because of its dynamism. Then the next pair, I think this is the last of the concepts, grounded and floating. Some architects like to ground their buildings, and most architects like to float them. And I bet lots of you students have a love affair with floating. Here's a building, Zaha Hadid, I believe, in Scandinavia. Oops. Where this wall is very grounded. It just plunges straight into the ground, like a tree plunges into the soil. But over here, the wall actually is floating because of this cantilever. And so the cantilever gives this sense of lightness and it's the opposite of grounded. And so in this one building, we see examples of grounding and examples of floating. In the Rolex Centre in Switzerland, the same thing actually. This curved slab, just a lovely sense of lightness, you know, of hovering, floating above the ground. And then yet, in other places, it's grounded. It again plunges into the ground, just like a tree does. In the Beijing airport terminal, we have these massive interior columns, and they are shaped a bit like trees. They are quite small in diameter at the top, and at the base they are very large, over 2 meters, because they have to work as vertical cantilevers for wind and earthquake loads. And so these are rather grounded, these interior structures. And yet in Japan we have this building here where the architect is trying to reduce the groundedness. In most buildings, the columns are the same size, or they get bigger near the ground. So normally, these columns would go like that, wouldn't they? But the architect has reduced the size to make the building less grounded. And actually the architect has introduced some high-tech, we call them dampers, to help the building withstand earthquake forces. And here's a building that we might say is floating in Rotterdam. Its supports are very light compared to the volume being supported. That's a 4-story building. A 4-story building. And notice the way it's built over some historic buildings. So the historic buildings are being preserved. But we would describe that building as floating. Very light structure here. Here's a structural core. Maybe that's housing the elevators. And there's another support at the back. A canopy structure made up of structural steel in Germany that appears to float. It's supported by just 4 columns. You can see one column here, and there's another column back there. Just 4 columns. But this is structural steel, and that enables the cantilever to be very slender. We couldn't build this in Indonesia or New Zealand because of the earthquake forces. This would be dangerous in an earthquake zone. So don't try and use this in Bandung, please. This is not such a good photo, but this is another building that is floating. This is an art museum. And it's the most wonderful art museum I've ever been into, because in plan it is gently curved. And the main gallery is in this steel box. And this steel box has only 2 supports, and it finishes with about a 30-metre cantilever. And so it looks as if it's floating. And when you go into the museum, the owner of the museum has written a statement, and he says how proud he is of his museum that is floating. He just loves his museum. So there we are. Those are examples of the way structure can reinforce different architectural concepts. Now I'm going to take you through the way structure can reinforce architectural qualities, which is a slightly different aspect. So these are the sets of architectural qualities I want to discuss with you. Because most of the spaces we design will fall somewhere between those ranges of qualities. So let's start with this spectrum. Simple to complex. You all know this building. The structure and the form are so simple, aren't they? It's almost boring by today's standards. Regular, vertical. The detailing is so simple. The whole building, apart from some of the internal planning, this was really quite simple. And in this building, also very simple. Just simple, it's a canopy, just simple vertical columns, steel beams, secondary beams, primary beams, and EFTE roof cladding. EFTE roof cladding. And so you can't really see any joints. Everything is just so simple and refined. But then we come to the Louvre, and then all of a sudden the structure becomes incredibly complex. And in fact, it becomes confusing because there's so many structural elements, thousands of them, supporting the pyramid. If the architect had wanted to, he could have used, say, solid steel beams, and maybe just, say, 12 of them, and that would have been enough. But he has used thousands in this complex structure. And here in this swimming pool building in Switzerland, the roof form is pretty complex. It references the nearby houses, so it's very nicely integrated into its like suburban environment. But the interior roof structure is incredibly complex, and all done out of laminated timber. What about qualities of openness and enclosure? Here's an atrium that is very open, and the structure is a diagram wrapping around the volume. And even the elevator structure is open. Exposed structural steel supporting concrete floor slabs. Even that is open. And so the whole of this architecture is to encourage transparency and natural light. And in London, that's very sought after because the climate is sort of quite miserable. Usually it's cloudy, you know, it's not very bright. And yet in Lyon, France, here's a closed architecture. Load-bearing concrete walls, just very narrow windows, and so the structure is creating a very strong enclosure, but yet inside we've got there's quite an openness. These are radiating roof beams and this interior atrium. So the structure is enabling these different architectural qualities. What about lightweight and heavy? This is one of the most lightweight buildings I've been into. In Tokyo, an exhibition centre, and all the structural members are using the minimum sizes, the most slender. Like, just let's start off with these bridges. They are box trusses for circulation. And look at the slenderness, you know, of the diagonals and the verticals and of the chords. Everything is small cross-section. Everything is light. And then we come to the main roof structure, which is incredible because the roof is supported on 2 columns. One column here, and the roof spans this way. It's an incredible inverted bowstring truss that looks like a skeleton of a whale or something. It's absolutely amazing. And look at the wall, the structure of the walls. There are no columns on the walls, no columns, because this takes all the weight of the walls. The walls are hanging and they are supported against wind forces by these cable trusses. The most lightweight that is possible. Cables. And here are some horizontal structure and more cables here. So this is an architecture of lightness. Here's a section. You can see the very unusual roof structure. These are the compression cords of the roof. Here are the cables taking the wind pressure. Here are struts transferring the wind pressures to a concrete, maybe in steel brace structure. Here are more cables for the wind forces. So very, very lightweight. And here is another very lightweight structure. This is a shade canopy in Kuala Lumpur, in Malaysia. And you can see how lightweight this is. This is the shade canopy. Here's a cable truss supporting it. It's spanning from here to here. And here are some compression members with another part of the truss. So very, very lightweight. And Jean Nouvel also was interested in lightweight, openness, and here are his trusses within this building. You know, no solid concrete beams, thank you, but open steel trusses to support the loads. And in England, we see how we can combine timber with steel to reduce the depth of the timber. So the structural depth of this bridge is this much, but the depth of the timber is only that much because of this steel, these steel cables. And we have a similar language to support the roof. Slender timber and using cables. Very lightweight. And we see Santiago Calatrava using this very light column, very strong steel column, supporting this massive reinforced concrete roof shell structure. But it's all supported for gravity loads by this single column, but it's supported against lateral loads by ties to the structure on the perimeter walls. Here's an example of heavy structure supporting a plaza above. These massive arches, they're about 2 meters deep. Massive structure forming these arches to support a very heavy roof there. And then to the Hong Kong and Shanghai Bank in Hong Kong. These structures actually are quite massive. They're quite intimidating because of their diameter, especially when they're in a small space. What about soft and hard? This is a very soft space, in my opinion. This is designed by Antonio Gaudi in Barcelona. Absolutely beautiful corridor. Just so soft and gentle. Just beautiful. So peaceful to walk through there. Just so peaceful. And then in this lecture theatre, with the curved glue laminated timber structure, you feel like you're in your mother's womb again. It's beautifully soft and rounded. And I think there's a trouble for the students staying awake in this lecture theatre. And this is the Tama Art Library, designed by Toyo Ito. There are almost no straight lines in this building. Even the structural grids are curved. Toyo Ito has curved structural grids. Imagine that. Imagine what the contractor would say. But we don't design for contractors. We design for the users of our building, don't we? We've got to remember that. And so when you go into this library, almost everything has a gentle curve. And there's this amazing sense of softness and peacefulness again. Even though the material is very harsh. And here are some shear walls designed by Toyo Ito. They make me laugh, these shear walls. They are fun, aren't they? Do you know any shear walls in Indonesia that are fun? Same in New Zealand. There are no fun shear walls in New Zealand either. But we've got to start designing them. in our works of architecture. What, they're like hands, aren't they? They're brilliant. And they will help express the design concept. That's the key thing. Every decision we make about structure, about everything, it must reinforce our design concept. That's how our architecture will be judged. And then a very harsh, very hard architecture. Hard materials, orthogonal, sharp edges, very, very harsh, very, very hard, very rigorous. And here in another live skin building, this is an amazing museum in memory of a Jewish artist who was murdered by the Nazis. And this artist, he hid from the Nazis for about 3 or 4 years before they found him. And everything in this museum is harsh. It's almost like going into a prison. The sheer walls have such sharp edges, you could cut your hands on them. They're so sharp. You know, everything speaks about a terrible experience leading to death. Amazing architecture of hardness. What about this spectrum? Elegance. This is elegant, isn't it? Look at this structure. It's pretty incredible. It's so elegant, it's like sculpture. Look at this column come shear wall. I don't know what to call it. It defies description, but it's helping support the floor slab above somehow. And then we move to detailing that is starting to become rough. And here, Kurt Himmelblau designed some very crude and rough structure. It's so rough. It's like it's designed by a first year student, you know, who doesn't know any better. But this is the architectural concept. Rough and hard. And here in Singapore, we have the School of Art, where the load-bearing walls are sort of rough, and the floors are all rough. It's like erosion. You get the sense of erosion in canyons as you walk through the campus. And then back to Gaudi, who uses very rough elements. Just, you know, raw rock, working in compression. Very totally rough. And so that's the end of my presentation. And so what are my conclusions? Well, my conclusions are that it's so important you make good use of your structure. You know, we can design structure that is dumb, that doesn't speak. Like, you know, these columns here, they don't really speak to us. If anything, they are rather annoying. But our job, you know, as young architects, your job as young architects, is to design structure that reinforces your architectural form and your architectural concept. And so every aspect of your structure should speak of your concept. If you are designing a building, for example, that is meant to be peaceful and meant to be enjoyable, well, please never use square columns. Use softer columns, you know, that are better for human habitation. And so I just encourage you to think of structure as an architectural element that can enrich your architecture. And then the challenge is for you, as well as doing that, to make sure that all of your buildings, all of your structures are very resistant to earthquake attack in both directions. And that, of course, is another story. Thank you.
Okay, now we have a